Hello everyone, my name is Anki Zhu, and today I'm pleased to present you our CVPR 2025 paper, Semantic-guided Cross-Modal Prompt Learning for Scatter-based Zero-shot action recognition. This research was partially supported by the Australian government through both the Australian Research Council's DCRA funding scheme and Discovery Project scheme. The practical work is completed with my collaborators, Jingmin Zhu, James Bailey, Mingming Gong, and Qiuhong Ke. Our research focuses on human action recognition, which is a crucial area in computer vision with important applications such as surveillance, healthcare, human-computer interaction, and intelligent environments. Within this field, scatter-based action recognition distinguishes itself through its accurate modeling of body joint-based movement and its natural protection of user privacy by abstracting away visual appearances. Moreover, scatter representations are robust to visual distractions such as background clutter or changing lighting conditions, while remaining its computational efficiency. These benefits make scatter-based methods especially suitable for the deployment in resource-constrained settings and have led to a surge of interest in the research community. However, a major limitation of current relative approaches lies in their dependence on fully supervised learning, where models are both trained and evaluated on a fixed set of predefined action classes. As a result, this framework is not as much as practical in real-world scenarios, given the enormous diversity of human actions and the high cost of comprehensive annotation for supervised training. To address this challenge, zero-shot scatter-based human action recognition has emerged as a promising solution, which enables the identification of unseen action categories without requiring label training data for these new classes. The key to an effective zero-shot learning is the establishment of robust knowledge transfer through a shared semantic space that can generalize well across the encoding output distributions of both observed training classes and the normal testing classes. The model can then classify the new examples for testing classes by leveraging the learned visual patterns from training classes which contain relevant semantics. Previous research has realized the practical training process of such methods by utilizing label embeddings from pre-trained language models such as BERT or CLIP as the learning reference for such encoding output distributions. Through carefully designed augmentation towards the label test, the model can further expand the scope of learnable transfer knowledge and thus improves the zero-shot learning performance. However, despite their effectiveness, these augmentation strategies heavily depend on artificial assumptions to guide the refinement directions. Consequently, the success of these approaches remains highly sensitive to the quality or consistency of human design choices, potentially introducing noise or irrelevant information that may hinder rather than help the scatter-to-text alignment. To avoid this issue, our paper introduces a novel approach that only uses learnable prompt tuning to realize the similar or even better optimization brought by such semantic augmentation. Specifically, we explore prompt tuning on both the text side and scatter side to enable automatic extraction and alignment of key semantic cues embedded in each action label. This helps reduce the reliance on any artificial assumptions, and by automatically capturing task-refined cross-modal semantics from the labels, this model can now focus on more consistent context shared across similar actions, eventually allowing it to establish more generalizable visual patterns that can define each potential new action. However, during our implementation, we noticed that there lie with two important problems that need to be carefully solved. One is that the existing literature has not yet explored how prompt learning can be effectively incorporated into scatter feature-based encoding. The other is that under the zero-shot learning scenarios, tuning instability still exists for common learnable text-based prompting methods, as they do not consider the overfitting issue on local classes. Following this motivation, we present our semantic-guided cross-modal prompt learning method, which provides individual solutions to solve the two problems we have mentioned. Specifically, for the language side, we propose a dual-string language prompting module that enhances the semantic extraction capabilities of a pre-trained CLIP text encoder. It particularly improves its generalization to refine the textual features for novel classes. For For the skeleton side, we introduce a semantic-guided skeleton prompting module that learns joint-shaped prompts to refine the skeleton features. It utilizes an adaptive visual representation sampler to implement the cross-modal prompted feature alignment at the end. The prediction is conducted by projecting final skeleton feature output to the text embedding space and find its nearest semantic class neighbor. During the training, our method only learns the parameters from the additional prompting modules and the projection layers, while keeping the weights of each backbone frozen. In details, for our language prompting module, in each text encoder layer, the dual-string language prompting will encode the layer inputs using a prompted string to do the task tuning knowledge enhancement. But before the prompted encodings go through the self-attention-based feature extraction, it will be embedded with the context attention from the origin layer encoding of the label test to maintain the semantic generalizability. And for our skeleton prompting module, we integrate a virtual skeleton join to record the prompting tuning information on the skeleton side. This new skeleton join follows the same feature data format from the other skeleton join, so that later we can concatenate the features of both real and virtual skeleton joins together as a complete joint feature sequence. And then we can use cross-attention with the text embedding output as queries to yield a visual representation that adaptively matches the corresponding cross-modal semantics. For the experiment result, using a dataset of NTU-60 and 120, our method reaches the best prediction accuracy compared to all previous milestone methods for both pure zero-shot learning baselines and the harmonic metric of the generalized zero-shot learning baselines. Finally, our ablation study conducted a thorough examination by testing the gradual removal for each of our proposed prompting learning modules. The results are horizontally compared with the performance of the full model. Especially, we also tested the versatility of our language prompting module, proving that our solution can also benefit other prompting-related tasks, such as image-based base-to-novel generalization. For more information and visualization experiments, please refer to the corresponding details in our paper. That's all for the presentation, and thank you for watching.